Hello everyone, welcome to Compiler Design video series. In previous video we have already discussed about what is translation process, why we use compiler, what are the features of compiler, task of compiler, types of compiler, application of compiler, language processing system, comparison of compiler, assembler, interpreter, etc. If you have not seen that video, then first watch this. In today's video, which topics we covered? Phases of compiler. In phases of compiler, it's analysis, synthesis, model, and front and back end of compiler. Then what is the structure of compiler, or what are the phases of compiler? Up to this point we have treated a compiler as a single box that maps a source program into semantically equivalent target program. But if we open up this box, we see that there are two parts to this mapping. So compiler can broadly be divided into two phases based on the way they compile: analysis phase and synthesis phase. In analysis phase, the analysis part breaks up the source program into constituent pieces and imposes a grammatical structure on them. It is also known as the front end of the compiler. The analysis phase of the compiler reads the source program and divides it into core parts and then checks for lexical, grammar, and syntax error. The analysis phase generates an intermediate representation of the source program and symbol table, which should be fed to the synthesis phase as input. Next is synthesis phase. Synthesis part construct the desired target program from the intermediate representation and the information in the symbol table. It is also known as the backend of the compiler. The synthesis phase generates the target program with the help of intermediate source code representation and symbol table. So compiler can have many phases and passes. So what are the difference between pass and phase? Pass we already discussed in our previous video. A pass refers to the traversal of a compiler through the entire program. According to pass, we have divided compiler into three different parts: single pass compiler, two pass compiler, and multi-pass compiler. Then what is the phase? Phase of a compiler is a distinguishable stage which takes input from the previous stage, processes, and yields output that can be used as input for the next stage. So a pass can have more than one phase. So analysis, synthesis, model of compiler, or front end, back end of compiler. Then first, source program. Source code is an input to analysis phase. It generates intermediate code representation or intermediate representation, which is also known as front end of the compiler. This generated intermediate code representation is input to the synthesis part, which generate the machine code, so which is known as the back end of compiler. So here you show the analysis, synthesis, model of compiler, or front end, back end of compiler. Then what are the phases of compiler? There are mainly 6 different phases of compiler. First, you have to pass the source program. Source program is passed to the lexical analyzer. Lexical analyzer scans the source program and generate it into token. Later on we will discuss it with the help of example. Lexical analyzer gives the input to syntax analyzer. Syntax analyzer gives the input to semantic analyzer. It gives input to intermediate code generator. The output of the intermediate code generator take as an input to the code optimizer, which is machine independent. The output of code optimizer is give as an input to code generator, and finally your target program is generated. All these phases are connected with symbol table. Here you show all these phases are connected with symbol table, and also error handler. If any error is generated, then error handler gives the notification. Symbol table is a data structure which stores the basic information, which is a lexemes, tokens, or any identifiers, variables, keywords, whatever informations in symbol table. So here I show the example which convert the source program into target program. So for example, I considered position equal to initial plus rat into 60 as a source program. You have any higher level programming or any instructions as a source program. Then what is source program? It is a program written in language other than machine code, typically a high level language. Source program is a text file that contains instructions written in a high level language. It cannot be executed by a processor without some additional steps. So a source program is also called a source file, source code, or sometimes just source. Here I take one example. Position equal to initial plus rat into 60, or any other example like A equal to B plus C into 8. So you can take any example. With the help of this example, I can show you how all phases are work from source to target program. First phase is lexical analyzer. Source program is passed to lexical analyzer. So it generates token stream. Then what is token? So token is a pair consisting of a token name and optional attribute value. The token name is an abstract symbol representing a kind of lexical unit. For example, a particular keyword or a sequence of input characters denoting an identifier. The token names are the input symbols that the pass processes. In what follows, we shall generally write the name of a token in boldface. So we will often refer to a token by its token name. The first phase of a compiler is called lexical analysis or scanning. This phase scans the source code as a stream of characters and converts it into meaningful lexemes. Then what is lexeme? Lexeme is a sequence of characters in the source program that matches the pattern for a token and is identified by the lexical analyzer as an instance of that token. Then what do you mean by pattern? A pattern is a description of the form that the lexemes of a token may take. In the case of a keyword as a token, the pattern is just the sequence of characters that from the keyword. For identifier and some other tokens, the pattern is a more complex structure that is matched by many strings. So lexical analyzer scan the source code as a stream of characters and converts it into meaningful lexemes. So lexical analyzer represents this lexeme in the form of token as token name and attribute value. Here we use example position is equal to initial plus rat into 60. So position is a one type of identifier. In this example there are more than one identifier, so I can identify it by number. So first is position, so identified as identifier 1, then is equal to, which is the assignment sign. Initial is also a identifier which is identified by identifier 2, then plus, which is the plus sign or addition sign, then rat, which is the identifier identified by identifier 3, then multiplication sign, then here is the number, so gives the number 60. So how this source program position equal to initial plus rat into 60 is identified after lexical analyzer. First, your source program, which is position equal to initial plus rat into 60, it gives to lexical analyzer, which generates token stream in the form of identifier 1 is equal to identifier 2 plus identifier 3 into 60. It generates the token stream. Then this token stream is passed to the next phase of compiler, which is syntax analyzer. Here you show position is identified by the identifier 1, so I can write here id comma 1. It is doesn't matter that you can write directly id 1 or id comma 1. So next phase is syntax analyzer. So next syntax analysis, this phase is called the syntax analysis or parsing. It takes the token produced by the lexical analysis as input and generate a syntax tree or parse tree. In this phase, token arrangements are checked against the source code grammar. For example, parser checks if the expression made by the token is syntactically correct or not. In this example, now I have token stream which is generated from lexical analyzer. It passes to syntax analyzer, which generates the syntax tree. Syntax tree is generated according to its precedence. All of you are very well know that the precedence of multiplication is higher than the addition. Scanning from any expression is from left to right. So for generation of syntax tree, first id 3 into 60 is executed. id 3 and 60, multiplication of identifier 3 and 60 is first executed. Then answer of id 3 into 60 is add with identifier 2. So answer of multiplication of ID 3 and 60 is add with identifier 2. So result of this expression is assigned to identifier 1. So result of this expression is assigned to identifier 1. So now you can see here the generation of syntax tree or parse tree from the given token of stream, which is generated by lexical analyzer. Lexical analyzer generate the token stream which is passed to syntax analyzer, and syntax analyzer generate the syntax tree according to token stream. If any error is occurred, then it generates the error and notify the error handler which detects the error. This syntax tree is give input to the next phase of compiler, which is semantic analyzer. Then semantic analyzer uses the syntax tree and the information in the symbol table to check the source program for semantic consistency with the language definition. So semantic analysis checks whether the parse tree constructed follows the rules of language. For example, assignment of values is between compatible data types and adding string to an integer. You already know that whenever you have to perform any operations, then operand types must be matched. You can't add one integer with one string. So also the semantic analyzer keeps track of identifiers, their types and expressions, whether identifiers are declared before use or not. An important part of semantic analysis is type checking. While the compiler checks that each operator has matching operands, the semantic analyzer produces an annotated syntax tree as an output. So from syntax tree, from the syntax analyzer, it passes to the semantic analyzer, which generates the annotated parse tree. Then what is the annotated parse tree? It is nothing but a parse tree with its types. So here you can show that there is one type checking, integer to float. You can easily understand that you can convert any type from smaller to larger type easily. So here it generates the syntax tree with its type checking, integer to float. Here you can write 60 or 60.0. So it also generates a syntax tree and pass it to the next phase of compiler, which is intermediate code generator. So next, intermediate code generation. In the process of translating a source program into a target code, a compiler may construct one or more intermediate representations which can have a variety of forms. After semantic analysis, the compiler generates an intermediate code of the source code for the target machine. It represents a program for some abstract machine. It is in between the high level and the machine level language. You can say that intermediate code generator phase is the bridge between analysis and synthesis phase. This intermediate code should be generated in such a way that it makes it easier to be translated into the target machine code. An intermediate form called 3-address code, which consists of a sequence assembly like instructions with 3 operands per instruction. Each operand can act like a register. In 3-address code, you can use maximum 3 operands. So in between 3 operands, you can use maximum 2 operators. So from Semantic Analyzer output, it can generate intermediate code generator. So how it generates? Here is the output of Semantic Analyzer, which gives to the intermediate code generator, which generates the intermediate representation. In intermediate representation, first it converts this procedure integer to float. Which number? Number is 60. So integer to float, then store it in any temporary variable. Here I can use more than one temporary variables, so I can identify this variable by T1. You can use any name of this variable. So first integer to float 60, result of integer to float 60 is stored into the variable T1. Then result of this is stored in T1, which is multiplied by ID 3. So here I can write ID 3 into T1. Result of this expression is stored in another temporary variable T2. Here you can see that I used maximum 3 operands, T2, ID3 and T1. In between these 3 operands there are 2 operators. So this is the form of 3-address code, maximum 3 operands. Now result of ID3 into integer to float 60 is stored in T2, which is add with ID2. So next phase is ID2 plus T2. Result of this expression is stored in temporary variable T3. So ID2 plus T2 stored in T3, but our result is stored in identifier 1. In this case we got our result in variable T3. So value of T3 is stored in identifier 1. So next step is ID1 equal to T3. Value of T3 is stored in identifier 1. Note that if you generate the intermediate code, then don't change in any original form of expression. This intermediate representation gives the input to the next phase of compiler, which is code optimizer. So next phase of compiler is code optimizer. In code optimization, machine independent code optimization phase attempts to improve the intermediate code so that better target code will result. Better target code means faster, but other objective may be desired, such as shorter code or target code that consumes less power. Better it means it will be faster or shorter. So next phase does code optimization of the intermediate code. Optimization can be assumed as something that removes unnecessary code lines and arrange the sequence of statement in order to speed up the program execution without wasting resources in terms of any CPU or memory. Here meaning of the original instructions does not change, just optimize the given code with removing unnecessary code lines. After generating the intermediate code, we got that t1 equal to integer to float 60, t2 equal to id3 into t1, t3 equal to id2 plus t2 and id1 equal to t3. This intermediate representation passed to the code optimizer, which generates the optimization code. In optimization code for this code, it directly considered id3 into 60.0. In this step, here integer to float 60, which is represented as 60.0, id3 into t1. This step is removed. So id3 into 60.0, result of this is stored in any temporary variable which is t1. So t1 equal to id3 into 60.0. Then t1 is add with id2. So final result is stored in id1. So next phase is id1 equal to id2 plus t1. So here 4 lines code will be optimized by these 2 lines, and there is no any meaning change from this expression to this expression. This code optimizer is target machine code, which is passed to the next phase of compiler, code generator. The code generator takes as input an intermediate representation of the source program and maps it into the target language. In this phase, the code generator takes the optimized representation of the intermediate code and maps it to the target machine language. The code generator translates the intermediate code into a sequence of relocatable machine code. Sequence of instructions of machine code performs the task as the intermediate code would do. In code optimization, I get t1 equal to id3 into 60, id1 equal to id2 plus t1, which is the target machine code, gives to the code generator, which generates the code. Let first load any register. I can use more than one register, so identify it with R1, R2, R3, etc. Then for floating point number, we can use instructions load for float point number. So LDF. These instructions you have already studied in your microprocessor. So ID3 is stored in register R2. Then after multiply it with 60. So multiplication MULF R2 with number 60 and again store it in register R2. So this result is stored in R2, which is add with identifier 2. So first load any register and store this identifier. So load F register 1 and ID2. So load register and store the value of ID2 into R1. Then after add this value with R2. So add F R1 comma R2 and this result is stored in R1. So I can write add F R1 comma R1 comma R2, but my result is stored in ID 1. Here I got result in R1. So value of R1 is stored in ID 1. So for store the instruction is ST. For floating point it is STF. So STF ID1 comma R1. So result of R1 is stored in ID1, which is your target program. It is a machine dependent target machine code which is known as target program. So here you can see that how the source code is converted into target program. Your source code is position equal to initial plus rat into 60, and your target code is converted into machine code. So first your source code written in any language which is passed to the different phases of compiler, and finally it generates the target code which is machine can easily understand. So source program is passed to the lexical analyzer. It generates the token or stream which is passed to the syntax analyzer, which generates the syntax tree, passed to the semantic analyzer which generates the annotated parse tree. It passed to the intermediate code generator which generates the 3 address code. This 3 address code is passed to the code optimizer which optimizes the code, and this optimized code is passed to the code generator. Then finally your target program is generated. Symbol table considered all token, variables, identifiers entries in it, and error handler generates any error if occurred. So this is the translation of an assignment statement. Next is front end back end of compiler. We already discussed analysis synthesis phase. In analysis part is also known as the front end of compiler. So front end consists of those phases that depends primarily on source language and mostly independent of the target machine. It includes lexical analysis, syntax analysis, semantic analysis, intermediate code generation, and creation of symbol table. The synthesis part is called backend of compiler. Backend consists of those phases that depends on target machine and don't depend on source program. It includes code optimization and code generation phase with required error handling and symbol table representation. So this is the phases of compiler or structure of compiler, analysis synthesis model of compiler, or front end back end of compiler. So in your exam, which types of questions are asked? First is what is compiler, then explain structure of compiler. You have to write definition of compiler, then explain structure of compiler from source program to target program with all the phases of compiler. Explain phases of compiler, structure of compiler with example. In this video we have considered example like position equal to initial plus rat into 60. You can write any example. Explain analysis synthesis model of compiler. Explain front end back end model of compiler, or any specific example is asked in your exam. write output of phases of a compiler for a is equal to a plus b into c into 2 type of ABCR float. This type of any examples are asked in your exam. For this example, identifiers are generated like for a, its identifier 1 is equal to means assignment sign. For a, its identifier 1 because these both are same, so identifiers are same. Then plus addition sign, then b identifier 2, then multiplication, it's a multiplication sign. For c, it's identifier 3, next multiplication sign, then number 2. So this type of examples are asked or any questions in your exam. Thank you.